Text tracking nature's vital signs. Caves. By the National Park Service, Klamath Network Inventory and Monitoring Program. Alice Chong McAlbury, Program Manager, Inventory and Monitoring Program, Klamath Network.
The Klamath Network Inventory and Monitoring Program monitors vital signs or indicators of ecosystem health in parks in southern Oregon and northern California. We chose to monitor a range of vital signs that represent all the different ecosystems in our parks, ranging from things like bird communities, vegetation communities, to specific types of communities like the cave communities here at Lava Beds National Monument.
Text, Lava Beds National Monument. Volcanic landscape with hills in the foreground and background. Rocky entrance to a cave.
In Lava Beds National Monument, there's this whole unique world under your feet because there's hundreds of caves. And no two caves are exactly alike. There's a lot of variety in volcanic cave formation, where some are short and shallow and others are multi-level and can go very deep below the ground.
Scientist with hard hat climbs out of a deep hole.
Caves have their own amazing ecosystem that includes water and ice, that supports all kinds of life, plants and animals.
Bird sits on rock. Small plants grow at entrance of cave.
We call our program the Vital Signs Monitoring Program because it's like monitoring vital signs in humans. For example, we monitor vital signs like blood pressure, pulse rate, your body temperature, cholesterol levels, your blood chemistry, in order to understand when are those values going outside what you would consider normal and when you need to be concerned, when you might need to actually do something about it. So that's essentially what we do for park resources, plant communities, animal communities, understanding physical habitat and environmental conditions. Our long-term monitoring program collects information on these indicators of health of the ecosystems in the park.
Katrina Smith, Natural Resource Program Manager.
Everything within the cave system is connected to each other, so the deep part of the cave is influenced by the entrance, which is influenced by the surface. We've identified important metrics in all of these different pieces of the cave environment to measure.
A still photo of two bats in flight. Text, monitoring bats, Townsend's big-eared bat.
Townsend's big-eared bats are full of character. They're exactly like they sound. They have big ears. They use caves both in the summer and the winter for raising their pups in warm caves in the summer and also for hibernating in the winter. They move around within the cave environment, but they use caves to complete their full life cycle.
A bat clings to a rock wall. Two bats in flight.
We're trying to measure population changes in Townsend's big-eared bats over time, and so the best way to do that is to count them when they're hibernating. So we've identified large hibernacula within the park, and we enter these caves to survey for bats, look around and count all the bats that we see. When we enter, we're going to be quick and quiet, as usual. Scan the ceiling and walls for bats. I'll take the middle. If you want to take the right wall and you take the left wall.
Scientists walk through the cave, looking around.
When we're looking for bats in a cave, they can be really hard to spot. One bat here. Townsend's single. They blend into the lava sickles on the cave ceiling, and they're just a small, fuzzy creature. When they're hibernating, bats are very sensitive to disturbance, and we don't want to induce extra stress. We only visit each site once per year.
They use helmet lights and a flashlight to scan the ceiling and walls.
Large groups of bats can be difficult to count because they roost on top of each other very close together. So if we see a large cluster, we take a photo so that we can zoom in later and individually count each bat nose.
Still photo of a small bat with white fungus on the nose. Text, emerging threat, white nose syndrome.
White nose syndrome is a disease caused by a cold-loving fungus that thrives in these cold and damp caves. It infects bats, it grows on their skin, it causes bats to wake up more frequently during their hibernation, and therefore they can often starve to death because they've used up all their energy reserves. And this can cause huge mortality in populations of bats that are hibernating during the winter.
A map of America highlighting portions of the Midwest and Northeast. Text, spread of white nose syndrome 2012.
In 2016, scientists were really surprised when white nose syndrome actually showed up in Washington state. It made a big jump across the country over to Washington. Washington's not that far from us here in Lava Beds National Monument, so our monitoring of caves and the bats hibernating in the caves, we should have an early warning system of the arrival of white nose syndrome here in the park.
Text, monitoring cave ice, crystal ice cave.
Ice caves are one of the best parts of the park. I think they're really unique, they're super cold. It's crazy to see frozen water underground.
Several ice formations in the cave.
So we're interested in monitoring ice caves because we've seen loss of ice over time in some of these places.
Masses of ice on ground. Waterfalls of ice on walls.
We use both photo monitoring and direct measurements. So we take photos of features that are difficult to measure or maybe have more seasonal variation, and we directly measure ice floors. So we're looking at the change in volume of ice over time. And because we don't know what the bottom of the cave looks like, all we can measure is the top of the ice surface. And so we're taking individual measurements to the edge of the ice floor and trying to calculate the volume of loss.
A man uses an instrument to take a measurement of a mass of ice on the ground.
Water inside caves is a very valuable resource for all kinds of different wildlife. Within the cave, the frozen ice can create this microclimate where cold-adapted species can thrive, but also melted water that's accessible to larger animals can serve as a source of drinking water for mountain lions and bears and bobcats. A lot of birds and squirrels and other types of small mammals use that water source as well.
Video footage from different times shows a fox, skunk, bird, and bear drinking from a pool within a cave.
Our job is to detect change in these systems, share it with the parks, and help inform this greater conversation about what's changing in our ecosystems and what can we do about it.
Larry Whalen.
It's important to have credible information, and scientific data is absolutely critical. I don't have the opportunity to go to guess about the management of lava beds. I have to know that direction, and that direction comes through scientific information, data sets, and people that know this landscape. That's why it's important to have inventory and monitoring come in and do the work that they do.
By monitoring these different components, these different elements, the biological, the plants, the animals, the physical environment, and the conditions like temperature and humidity, we help the parks understand how all these components of the ecosystem interact and affect one another. And with that greater understanding comes better management. Why do we do it? We do it because we're really passionate about the resources, the caves, the plants, the animals that are in the park. And we feel this is really vital work to protecting our parks long into the future.
A view of the night sky out the entrance of a cave. Many stars move slowly across the sky, with an occasional meteor. The Klamath network includes Crater Lake National Park, Lassen Volcanic National Park, Lava Beds National Monument, Oregon Caves National Monument and Preserve, Redwood National and State Parks, Toole Lake Unit, Whiskeytown National Recreation Area. Special thanks to David Riggs, Jamie Stevens, Randall Paler,